I mentioned in a previous video the talk of substitution when taking an integral, and this is how to do it. The theorem is from your book. It is a little bit convoluted. An example will hopefully clarify it a bit. So essentially, we're going to have a product of things, and we're going to take one of the products or part of one of the products, turn it into or substitute it for the letter U, and the derivative of that should clean up the rest of it, essentially here. So if you notice, we're going to let U, there we go. We're going to let U be equal to this G of X, and G of X is right there. Now, you notice we have an F of G of X. That's equivalent to saying, so remember, F of G of X is really a composition, F of G at X. Okay? So it's a composition of two functions. So in our example down here, our G of X is equal to sine, I guess we'll call it sine of X instead of theta. And our F of X is going to equal X to the 7th power. And that will get our composition of sine of X to the 7th power, or sine of theta to the 7th power. All right, and then we have the other part here, G prime of X. Well, the derivative of our G, so G prime of X, derivative of sine of X is cosine of X. And that's what we have, well, cosine of theta in this case. Okay? So we have a product of two things that fit this form, and we're going to be able to substitute with it to solve the problem. Now, typically our strategy is to find a product, something like this, where the derivative of one equals the other, or equals something very similar to the other. As here it's going to be fine, but in others we may have a constant multiple of it that we'll have to deal with, which shouldn't be too bad. And there's others where we have to change the substitution. I'm not going to cover that in this class, but there are other ways as well. So with this problem here, let's just scroll down a little bit. And so here, we're going to let our U equal sine of X, or we'll call it, sorry, we'll keep it theta, sine of theta. So our du, which is a derivative with respect to U, derivative of sine is cosine, and then d theta. So the d theta means just the derivative of respect to theta, with respect to theta. So we can then rewrite this as the integral of U to the 7th power du. So that's what this equals. Bit of a mess, I apologize, but this is the basic form of it. Now we know how to take the antiderivative of U to the 7th, or X to the 7th, or whatever. So this is equal to U to the 7 plus 1 over 7 plus 1, and then we have a plus C, which equals 1/8 U to the 8th plus C. And our last step is we're just going to substitute back in. We're going to replace our U with what it actually was. So this equals 1/8 sine to the 8th power of theta, and then plus C. Because again, the derivative of C is going to equal 0, and there's no issue. And you see this is fairly easily through the chain rule. Our 8 comes down and multiplies by the 1/8, which gives us 1. Then we have sine to the 7th power, and then we have to multiply by the derivative of sine, which is cosine. And that gives us what we had initially. All right, let's do one more example. All right. with this one here, uh, we have, instead of a product, we have a quotient of two things, or we can have a product of 1 over this our numerator, our denominator, multiplied by just x squared. But if you notice in the inside here, if we take this whole part as our u, or what would be g to the x, when we take the derivative of that, we're going to get what's in the numerator, or something close to it. So here, we're going to let u, that's not what I want. We're going to let u equal x cubed minus 3. And I have to give it the whole thing. I can't just make it x cubed. But you'll notice when we take the derivative, that's 3x squared dx. The derivative of negative 3 is just 0. All right, so we're going to substitute in for our u there. But we also need to substitute the du in there. Now, if we note here, I guess dx. So our du is equal to 3x squared dx, but we only have x squared. We don't have the 3. So what do? Well, typically we're just going to multiply by the reciprocal here. So our x squared dx, with a little bit of algebra, will be du over 3 is equal to x squared dx. And this is what we're substituting for. We have an x squared dx in our numerator. So then this is going to equal 1/3, because we've got the 3 in the bottom there, 1 over u squared du. And this is something we can take the integral of, because this is 1/3 integral of u to the negative 2 du, and that's just the simple power rule. So this is equal to 1/3 times u to the negative 2 plus 1 over negative 2 plus 1 plus c. Scroll down a little bit before we start substituting. You know what? I'm just going to write it over here. So we'll bring it up here. So that's 1/3 u to the negative 1 over negative 1. And this equals negative 1 over 3u plus c. All right, but again, we have to substitute back in for the u. Our u is x cubed minus 3. So this is equal to negative 1 over 3 times the quantity, x cubed minus 3 plus c. And that's how we do it. And we can do a few more of these in another slide.